Hello everybody and welcome back. We're going to be looking at question number 17 on the grade 8 multiple choice contest from the year 2001. So the grade 8 Gauss. As I say, we're at question 17 and it's about a fellow named Daniel. So Daniel's age is 1/9 of his father's age. 1 year from now, Daniel's father's age will be 7 times Daniel's age. Okay? The difference between their ages is. Alright. So with questions like these, I often find that they can get quite confusing. Because our instinct is to introduce a variable for Daniel's age. We could call it D. And so anytime we see Daniel's age in the problem, we start thinking, oh, that should be D. Maybe his father's age is F. But the problem is we have sort of a time scale here. The Daniel's age that they talk about in that first sentence, Daniel's age is 1/9 of his father's age, is different than the one in the second sentence. 1 year from now, Daniel's father's age will be 7 times Daniel's age. So it's not D equals 1/9 F, and then F is equal to 7D, because of that little phrase there, 1 year from now. Okay, so Daniel's age has changed, and we have to change our variables accordingly. Okay, so we could either say D plus 1, or we could introduce another variable, maybe call it capital D, and that'll be Daniel's future age. So these are both excellent ways to handle this sort of question and keep track of the actual quantities that we're talking about. Okay, so I'm going to say let D be Daniel's age now, as opposed to in 1 year. And let F be his father's age now. Okay, in 1 year, D plus 1 is equal to Daniel's age. And F plus 1 is the father's age in the future. Okay? Now I am told initially that D is 1/9 of the father's age, so D equals 1/9 F, and that next year, the father's age, so next year's father's age, so the father's age in the future, is 7 times Daniel's age. Okay? But that's Daniel's age 1 year from now, or Daniel's age in the future. So with questions like these, the problem is actually just setting up and getting the right equations that actually represent the situation that we're talking about. Okay? But now we have a bunch of equations and we can start solving for things. So this first equation, well, I don't like the 1/9 there. I'm going to rearrange and make it 9 times Daniel's age is his father's age. So now I have F in terms of D. I can substitute that in. So 9D plus 1. And I can expand this side is 7D plus 7. I'm going to collect like terms. I'm going to bring my 7D over to the other side by subtracting both sides by 7D. And I'm going to bring this 1 over to the other side by subtracting both sides by 1. So we have 2D is equal to 6. And that very quickly translates into Daniel's age is 3. And that's Daniel's age now. Now, if you wanted to, you could do a little check. Okay, if this is Daniel's age, what's his father's age now? 27. Okay. So we just do a little check over here on the side. D equals 3 is our answer, and if we're confident in our working, we can bubble it and move on. But his father's age will be 27. So that means next year, Daniel's going to be 4. And his father's going to be 28. And we just double check, does that satisfy the other relationship? Next year, his father will be 28. That's 7 times 4, which will be Daniel's age in 1 year as well. So it looks like we're all set. So D equals 3. My mistake. D equals 3 is the final answer we want. Oh no, sorry. The difference between their ages is. Okay. So the father is 9 times D. So that's going to be 27, and we want F minus D. So that's 27 minus 3. That's going to be 24. Okay. Now, fortunately, they did not put 3 as any one of the possible answers here. So we would have realized there was a problem immediately, and we would have reread the question. So we want the differences of their ages. That's A, 24. All right. So that's question 17. In the next video, we're going to take a look at question 18. And hopefully you guys will join me for that then.